So the best news for this review is that the test is all multiple choice. So let's get started with the review. I know the notes are not very long for this chapter, but you should still look over them. Don't forget those left side activities that you could practice for extra practice for naming and writing formulas, because that's what this test is going to be about, and answering a few questions about how you do go about naming them. So let's get started on the first question. Question 1 says a chemical formula for an ionic compound is represented by a formula unit, and a chemical formula is called, for a covalent, is called a molecule. We also sometimes call covalent compounds molecular compounds because they are forming molecules. Next. Rules for writing formulas for compounds. We'll talk about ionic first. This is for just writing, not naming, so just writing. When we're writing a formula, we always write, for ionic, we always put the cations first, the anions second. We balance the charges using the subscripts, and we want the smallest whole number ratio. So this example here is calcium bromide. I got a +2 here and a -1 there. So I need both sides to be a total of a 2, so the positives can cancel out the negatives. So in that case, I would use 2 total bromines. So I would write it as CaBr2. If I'm writing a formula for a covalent compound or a molecular compound, they're the easiest of all because we literally just write what they say as far as the prefix. So this is dinitrogen trioxide. Di is 2, so that formula would be N2. Trioxide is 3, so it'd be N2O3 would be its formula. You must know your prefixes for the test. That mono, di, tri. Make sure you look over those from the first page of your notes. On this page, we're going to write the formulas. I went ahead and put some of the charges in there so you didn't have to look them up. You do not get to use that pink sheet that we did all those ion quizzes over on the test. So you have to know those. Remember to make sure you look over and know the charges based on where they're located. Remember, a group 1 is a +1 charge. Group 2 is a +2 charge. Group 13 is going to be a +3. And then, of course, group 14, we don't give it charges. And then it starts going down, starting with group 15 is a -3. Group 16 is a -2, and group 17 is a -1. You should have labeled that on your periodic table. Okay, so here we go. Let's try this. So this first one is zinc chloride. Zinc is a +2. It's one of those transition metals that doesn't get a Roman numeral, so it's just zinc 2. +2, chloride is a -1, so we need to balance out those charges. So I'm going to use 2 chlorine to go with 1 zinc. That way I have a total of a -2 charge to balance out my +2. So that formula would look like this. Magnesium hydroxide is the next one. Same scenario. I've got a +2 here and a -1, so I'm going to use 2 of these to go with 1 magnesium. So when I write that, it would be Mg. Because hydroxide is polyatomic, we've got to put the parentheses around the entire thing and then say we need 2 of them. Okay? I want to caution you about hydroxide. I've seen a lot of people writing it like this, and that is wrong, because when you write it like that, this 2 right now is only going for the hydrogen that comes before it, and it's not counting for the oxygen. And so make sure you throw those parentheses around that hydroxide. So let's do the next one. There's a typo. It says lead 3. There is no such thing as lead 3. So it should be lead 4. So change that on your paper to be lead 4. This time we have a 4 plus and a 3 negative right here. So we're going to need to balance that charge out. So we can do one of 2 things. We can say I've got a multiple of 4 and 3, which is 12. So in order to make lead B12, I want to use 3 of them. So I would say PB4. Just kidding. Erase that. That would be PB3 to make that be a charge of 12. And then in order to make nitrogen be a charge of 12, I want to use 4 of those. And so that would be PB3, and 4 would be my final one. For the next one, carbon tetrachloride, when I see prefixes, My clue is to say that that's a molecular compound because I have two nonmetals. So I'm literally just going to write what it says. Carbon is C. Tetra means 4. So I would do Cl4. And that would be its formula. The next one also has prefixes. So it is diphosphorus trisulfide. So I'm literally going to write P2. And then sulfide is S and 3. So that would be its formula. And then the last one, tin-4 sulfate. This is a +4. This is a -2. In order to get them balanced out, I'm going to use 2 of these. So that would be a -4. So I would write that as SN. Again, with the polyatomic, we're going to put parentheses around it when we need more than one of them. And it'd be SO4 2. And that's what that would look like. Now rules for naming the compounds. So again, we're going to start with ionic. For ionic compounds, remember no prefixes. If it starts with a metal or that pesky little NH4 plus, we do not use prefixes. So the cation always keeps its name. The anion, if it's just an anion, it changes to IDE. So chlorine would become chloride. Fluorine would become fluoride. The polyatomics keep their name. So if it's sulfate, we just write sulfate. If it's nitrate, we write nitrate. And then we use the Roman numeral if it's a transition metal and if it's tin or lead, because they are not transition metals, but they can have more than one charge. When we're writing formulas for covalent compounds, that is where we use the prefixes. And remember, the first element keeps its name. So the first thing listed always keeps its name. And it only gets a prefix if there is more than one. The second thing always changes to IDE, and it always gets a prefix. Even if there's one, we call it mono. All right, so let's practice a few on the next slide. So that one's kind of stuck up there, so we're going to put this up here so we can see it better. And we see that that is sodium, so we write sodium. And then we have to look up this polyatomic ion. Remember, whatever comes after sodium goes together. So ClO3 is chlorate. So this would be sodium chlorate. Okay. Next one, 2 nonmetals. So when I see 2 nonmetals, I know to use prefixes. So first thing keeps its name, and there's only one, so it would just be carbon. Second thing changes to IDE, so we're going to say oxide, but remember the second thing always gets a prefix, and there's one, so we would do carbon monoxide. 2 nonmetals again. Sorry, those didn't get subscripted, but that's going to be 3 is tri, so it's going to be tri-nitrogen. And then 10 is dec, and we're going to say dec oxide. And remember, when there's a prefix and it has an A or an O on the end and you're putting it with oxygen, you drop off that O or A. All right. Next thing is a metal and a nonmetal. So we will not be using prefixes. So we're literally just going to name it sodium bromide. And the next one is that pesky NH4 plus. Remember, that's the only positive polyatomic, and that is called ammonium. And then the OH is hydroxide, so it would be ammonium hydroxide. Now remember, we do not use prefixes for ionic compounds because they can only go together in one way based on their charges. That's why they don't need prefixes. Next question says, what is the algebraic sum of the oxidation numbers? That's a fancy way of saying the charges in a compound. And remember, the algebraic sum always adds up to 0. We adjust subscripts in order to get them to do that. The most common oxidation numbers of the following, again, fancy word for charges. For hydrogen, we have a +1. For calcium, we have a +2. Boron's a +3. For carbon, it's not applicable because carbon doesn't get a charge. It's going to usually always share. Nitrogen is a -3, and oxygen is a -2, and then fluorine is a -1. Please remember to know things based on where they are on the periodic table. You will get a periodic table on your test, So you can look at that, but you will not be getting your ion or your pink sheet. So make sure you, at the very least, know how to tell what their charges are based on where they are on the periodic table. And then make sure you know those main polyatomic ions. Okay, this question is, where are the metals and the non-metals located on the periodic table? Oh my gosh, for the love of cheese and crackers, you should know that by now. We have the zigzag line on the periodic table, and the zigzag line is, this side is metals, this side is non-metals. Of course, if it's on the line, it's metalloids, but we won't need to worry about that for the test. And then also by now you should know, how can you tell if two elements are likely to form an ionic or covalent? Remember, ionics between a metal and a nonmetal, we don't use prefixes, we call those formula units. A covalent bond, which we also call molecular compounds, is two nonmetals. We use prefixes, mono, di, tri, etc., and we call those molecules. So please make sure you know that. Next question is, when naming a compound that has a transition metal, I would also add tin or lead because they also have multiple charges. We show that charge by using a Roman numeral. So 2 would be, if it was a +2, we would show that as Roman numeral 2. Which group doesn't usually form ions? And that's going to be your group 14, and it's going to be your nonmetals. Because down at the bottom of group 14, you have tin and lead, and they actually both form a +2 and a +4 charge, which we would show with Roman numerals. And this is our terms we need to know. I'm not going to read over those because you are smart enough to read them. I went ahead and wrote them out. These are very simple formulas. There's much more detailed formulas. I just gave you this synopsis of what you need to know basically. And then we'll go to the last slide. All right, last questions. Remember that cations always lose electrons. That's why they're positive. Cations are positive. They are formed by metals. The metals always lose electrons. They will never gain. They will never share. Okay. The anions gain electrons, and they usually are formed by non-metals. Remember, sometimes the anions can sometimes be the polyatomics. And of course, we have that one positive polyatomic, which is NH4 plus. And then the very last question is the transition metals that don't need Roman numerals, and they are zinc, silver, and cadmium. Those you just have to memorize, and when you would write those out, you would not write them with the Roman numerals. So if we were doing zinc, we'd say like zinc sulfide, and that's how we would write it because zinc is always a +2, and then it would look like that. Okay, stay tuned on the last slide for the jokes, and then we're done. All right, here we go. Some joke riddles for you today. First one, what kind of bow can't be tied? A rainbow. Next one, what has one head, 1 foot, and 4 legs? A bed. And last, what is worse than a worm in your apple? Half a worm in your apple. All right, make sure you study for your test. Oh, by the way, remember there's that quizzes link on Canvas if you want to do some extra practice before the test on Wednesday. All right, good luck tomorrow.